So far what we have covered is mesh analysis, node analysis, super mesh analysis and super node analysis, right? That we have done using dependent as well as independent sources. So dependent sources is the new thing introduced for you in the syllabus. In BW you had only independent sources. So next part of the module is DC network theorems. So you have already studied 4 network theorems: superposition, Thevenin's, Norton's and maximum power. So let's start with superposition theorem. So we'll use independent as well as dependent sources. So just to have an idea of it, since you have already done, let's start with the example. I'll directly start with the example since you have already done it. Now in none of the numericals it is mentioned using superposition theorem, because we are studying the topic superposition theorem, so it is assumed we'll use superposition theorem everywhere. So let's start with a simple numerical. Find current through 2 ohms resistor. So what is the first thing? To locate the 2 ohms resistor and to see whether there are any dependent sources. There are no dependent sources, right? So what is the step 1? There's no need to write steps in the exam. Just for the first time I am writing it. So let's say we consider only one source at a time, right? So when 40 volt source is acting alone, right? So rest all are replaced by their internal resistances, right? So what happens to a voltage source? It gets shorted. What happens to a current source? It gets opened, right? So let's redraw the network. So it is shorted here. So this is also shorted. So you see the sum has become very simple. We can just solve it using series parallel reduction technique. And this is 40 volts. So what we have to do? We have to find the current through 2 ohms. So as if you remember, we call this as I dash. Strictly speaking, it is called as I prime. So now from now on, I will call it as I prime. And let's say this is the total current I. If you want, you can name them I1, I2. But usually for superposition terms, we name them as I prime, I double prime, I third prime, and so on. So what we can do is we cannot touch this, right? But if we know the total current, it will be very simple to find the current I prime, right? So what we can do is we can first find the total current. So what will be the total current? We can find using which technique? By series parallel reduction technique. So what will it be? I will be total voltage V upon total resistance. So these two are in parallel, this common point and this common point. So and series with 5. So 5 plus 2 parallel with 10. You can write in this way also in the exam. So you can directly write the final answer. So 40 upon 5 plus. So what is this? 2 inverse plus 10 inverse and inverse of that. So I'll write in this way. So 2 inverse plus 5 inverse. So what is it? 6.22. So 6.222 amperes. Right? And it is going towards right. So what will be the current I prime? We can find using current division rule. So by current division rule, what will be I prime? It will be total current I, which is we have found out 6.222 into parallel resistance. What is we are finding the current through 2 ohms? So parallel resistance is 10 ohms. You have already done this. On total resistance of the loop, so 10 plus 2. So therefore I prime equal to. So we already have this into 10 upon 10 plus 2 is 12. So 5.185 amperes towards right. Fine. Next what we have to do? So we have got the current through 2 ohms using 40 volt source. So next step 2. When 20 volts is acting alone, right? So again 40 volts will be shorted. We'll draw it like this. 10 volts will also be shorted. So this is 20 volts, this is 5 ohms, this is 10 ohms, this is 2 ohms, right? So again current through 2 ohms. So this is I double prime, and this in the same way will solve for the total current type. Then we can use CDR. Fine. So again, by series parallel reduction technique, what will be I? Total voltage V upon total resistance. What is the total resistance? This 10 parallel with 2 in series with 5. So 5 plus 10 parallel with 2. But if you observe, current is going inwards. Now we know this is a positive sign, so this will throw current outwards, right? So this current has to be negative, right? So therefore I equal to 20 upon 5 plus 10 inverse plus 2 inverse. So it is 3 amperes minus. So therefore 3 amperes going this way. So therefore I equal to 3 amperes going the opposite way, right? So then what will be I prime? So we can write by CDR for current division rule. So total current, which is 3 amperes into parallel resistance 10 upon 10 plus 2, right? So therefore I double prime equal to. So now if you see here also, the current will be towards left. Why? Because this is throwing current like this. So here it should get combined. So I prime should be opposite. So this will be minus. The total current will be minus. So considering you are taking towards right, the term is negative, remember. So 3 into 10, 30 divided by 12. So 2.5 amperes. I'll write positive towards left. Fine. So next, when 10 volt source is acting alone. So step 3, when 10 volt source is acting alone. So again redraw the circuit. So this is 10 volts. Remember, this is positive, this is negative. It is given other way around. So again what we can do, we can find the total current and then use series parallel reduction technique. Now here we will be smart. We'll say this is I triple prime, right? So it is in the same direction, right? So if this is coming here, how will this current go? Like this. So it will come here like this. So this will be I1 say. I will not say I because it will cause confusion. Because current supplied by the battery and current through 2 ohms is same. So what will be I triple prime? It will be 10 upon 2 plus 10 parallel with 5, right? So you are directly getting I triple prime here. So it is 10 upon 2 plus 10 inverse plus 5 inverse. So 1.875 amperes, and direction is towards right. Make sure you write these directions. So what will write? This sentence which I am writing now, it carries 1 marks. So by superposition theorem, total current I through 2 ohms, it will be what? I prime plus I double prime plus I triple prime. So therefore I through 2 ohms equal to, so what is I prime? 5.185 plus I double prime. What is I double prime? 2.5. But this was towards right, this is towards left. So towards right, this will be minus 2.5. So minus 2.5. This is very important. And this is towards right only, so plus 1.875. So 4.56 is our answer. Ampere, it will resultant current will be towards right. This is our final answer, right? Let's solve next sum. So let's directly jump to which sources? Dependent sources. Find the current through 6 ohms resistor. So this is the 6 ohms resistor, and you observe we have a dependent source now. What is the value? 3i. So I should be given somewhere. So I is here, right? And one thing for dependent source, we will not consider it as a separate source, like saying when 3i acting alone, because it cannot supply current on its own. It has to depend on some other independent source. So we have only two steps here: when 15 volt source is acting here, and when 10 volt source is acting. So when 15 volt source acts, so dependent source will always be there. This you have to remember. So they will neither be shorted nor they will be open, irrespective of voltage or current source. But this is independent source, so this will be shorted. So this is 3i, this is 8 ohms, 6 ohms, 15 volts, and this I is original, which is given for this, right? So now what we have to do, we can solve this using mesh analysis, right? So this is I1, this is I2, fine. So what we have to find, don't forget that current through 6 ohms, that is we have to find I1, or in general I. So what we do first, we write I in terms of I1 and I2, because there are two meshes, we'll have two equations only, right? So for I1 we'll get one equation, for I2 we'll get another equation. But if we write in these terms, we'll get terms in I also. You have seen in previous lectures, right? So I should be written in terms of I and I1. So from this we can see I is nothing but equal to I1. So you can write from network I equal to I1, right? Then apply KVL at mesh 1. So what we will get? 15 minus 6 I1. But this is a current source, you don't know the value, so you cannot apply KVL at mesh 1, right? So this is not possible. So you observe there is a current source in between mesh 1 and mesh 2. So what does it form? A super mesh. So again you will write mesh 1 and mesh 2 form super mesh. I am using shortcuts, you have to write it completely. So therefore what we can say, I2 and 3 current source are in same direction. So therefore I2 minus I1 equal to 3i. Then we will write from equation 1, I is I1. So I2 minus I1 equal to 3 I1. So therefore, so I'll take it here. So 4 I1 minus I2 equal to 0. Equation number 2. Right? So next, apply KVL to super mesh. So 15 minus 6 I1 minus 8 I2 equal to 0. So therefore 6 I1 plus 8 I2 equal to 15. Equation number 3. Then what we'll do, solve equations 2 and 3 simultaneously. We'll get I1 and I2. So 4 minus 1, 0, 6, 8, 15. So what we get? Therefore I1 equal to I2 equal to 0.3947 amperes. Direction is clockwise, and this is nothing but I. We have seen it. So it is going towards right. This is what we require. So I2 is, I'll write I2 also. I don't think we need it, but then do 5, 7, 8, 9. Direction is clockwise, right? What is the question? Find current through 6 ohms. That is I, right? So let's say we make it I prime, because that is what we have to find. So this will be I prime. So we have found it. Next, what will we do? We'll say only 10 volt source acts, right? So again the positive terminal is downwards. This is 10 volts, this is 6 ohms, so this will become what? I double prime this will be I double prime, and this is 8 ohms, right? So here you will write when 10 volt source acts alone, right? So again we'll have I1 and I2. So this is I1, this is I2. So again it forms a super mesh. So we'll write mesh 1 and 2 form a super mesh. So I2 minus I1 equal to 3 I double prime. Before that we will say what? I1 equal to I double prime from the network. I am using shortcuts. So therefore I2 minus I double prime equal to 3 I prime. So therefore 4 I prime double prime minus I2 equal to 0, right? So therefore, so this is equation number 4, right? So next what we will do, apply KVL to super mesh. So minus 6 I1 minus 8 I2 plus 10. You are going from minus to plus, so rise in potential. So therefore 6 I1 plus 8 I2 equal to 10. Equation number 5. So solving simultaneously 4 and 5. This will be I1 is I double prime. So this will be I1, I1, I1. So we'll get I1 and I2. So 4 minus 1, 0. 6, 8, 10. So I1, which is nothing but I double prime, equal to 0.2632 towards right amperes. Don't forget the unit. I2 equal to 1.053 amperes clockwise. So therefore by superposition theorem, what will be total current through 6 ohms? I prime plus I double prime, and both are in same direction, so we just have to add them. This is ohms. So 1.053 plus 0.3947, so 1.4477. This is the answer, right? So next, let's solve one more sum and then we'll stop. So find voltage Vx. In the same way we find current, they can ask you to find current also. So again there is a dependent voltage source of value 3 Vx. So Vx should be present somewhere. So it is here. So what is the first step in superposition theorem? Obviously we have to solve using superposition theorem. So first step, let's say when 18 volt source acts. So when 18 volt source acts, what will it be? It will look somewhat like this. Sorry, this will be what? Open. This is open. And as I said, voltage source and current source, if they are dependent, they are kept as it is. So this will be shorted. So you get a single loop in fact, right? So what is this? 3 ohms, 6 ohms, 3 Vx, which is 18 volts, and this is plus minus Vx. So let's say current is I, right? So what is the first step? We write the dependent source wala equation. So what will it be? This is plus minus, current is flowing clockwise, right? So what will it be? This will be plus, this will be minus, because current flows from higher to lower potential. So what we can say, Vx is I into R by Ohm's law. So I is I, R is 3, so 3I plus 3I. Why plus 3I? Because both are same. If this was minus plus, this would have been minus 3I. So this is equation number 1, right? So then we write, so we apply KVL to the equation, or you can use Ohm's law. So applying KVL to the mesh, so 18 minus 3I minus 6I minus 3Vx equal to 0. So substitute 3I here. Therefore 18 minus 3I minus 6I is minus 9I minus 3 times 3I equal to 0. So you can solve this in calculus. So 3 3s are 9, so 18I. So therefore 18 equal to 18I. Therefore I equal to 1 ampere. No need of calculus. It is clockwise. So what is Vx? make this Vx prime because we are using superposition theorem. So therefore Vx prime equal to 3I. So Vx prime equal to 3 volts. This is the intermediate answer we get. So next, only 5 ampere source is acting. So when 5 ampere acts, so what will it be? This will be shorted, this will be shorted, 3 ohms, 24 ohms. This is plus minus 3 Vx, make it double prime. This is 3 ohms, 24 ohms, 5 ampere, and this is 6 ohms, 3, 6, 24. Yes, I am correct. And this is already given as plus minus Vx double prime, right? How will we solve this again? We have to find Vx double prime, right? So let's assume again currents I1, I2. So you see this is the sum of super mesh. So this and this direction is same. So what will we get? Before that we'll write Vx double prime plus to minus. So again plus 3I1. And then by super mesh I2 minus I1 equal to 5 amperes. Equation number 1. This is 2. This is 3. Then applying KVL to super mesh. So we get this. So therefore minus 3 I1 minus 6 I2 minus 3 Vx double prime equal to 0. What is Vx double prime? 3 I1. So therefore minus 3 I1 minus 6 I2 minus 3 times 3 I1 equal to 0. So 3 3s are 9, minus 9 minus 3 minus 12. So minus 12 I1 minus 6 I2 equal to 0. So I can make this plus. So this is equation number 4. So solving 3 and 4 simultaneously. So what will we get? I1 equal to I2 equal to. We require only I1. So we will not write I2. It's fine. So remember this is I2 minus I1. So first we'll take minus 1, then plus 1 because minus I1 plus I2. Then 5, then 12, 6, 0. Have I entered correctly? Yes. So you get I1 as negative. So it is actually clockwise. So this is 1.6667 amperes in this direction. Right? So what is Vx double prime then? So Vx double prime is 3I1. So that is what direction for clockwise. So for anti-clockwise it is what? It will be negative, right? So therefore Vx double prime equal to minus 1.667 into 3. So it is minus 5. Minus 5 volts, right? Again I will tell why is it minus. You understood this is plus 3I1. Why it was plus 3I1? Because current and these directions were same. That is current flows from higher to lower potential. It is going towards right. So this is higher, this is lower. So both are same. So you got plus 3I1. But what are we getting I1? This was I1 as clockwise. But we are getting I1 as anti-clockwise. So actually it is flowing in this way. So this is plus, this is minus. So Vx prime should be what? Minus. Right? So if you want, you can write minus here also. It's not an issue. Or you can write one sentence regarding that. So finally what we write by, no, we have one more source, right? Yeah, 36 volts. So when 36 volts acts alone. So this is shorted. This is again open. So no need to draw. So 3 ohms, this will be Vx triple prime. So this will be 6 ohms, 3 Vx triple prime. 36 is acting, so this will be there. So again we have a single loop. So this is I, right? So same direction again. So Vx triple prime equal to 3 I, right? But now we know this is what 36 volts. This current is obviously going to flow like this. So better take anti-clockwise direction, right? So now what is happening? This current is going anti-clockwise. So this is plus, this is minus. Current flows from higher to lower potential. So this will become what? Minus, right? Then what will we say? So we can apply KVL or we can use Ohm's law. So total voltage 36. Sorry, we'll go like this. We'll go like this. So plus 36 plus Vx. So 36 plus 3 Vx prime. Again, I went like this according to the current. So rise in potential, minus 2 plus upon total resistance is 9. 6 plus 3. And what is Vx triple prime? It is minus 3i. So therefore 9i equal to 36 plus 3 into minus 3i. So therefore minus 9. So here it will be 18i equal to 36. So I equal to 18 to the 36. So 2 ampere in anti-clockwise direction. So I can say towards left. So what is Vx 3 pi? So we are getting the direction as positive, right? So Vx triple prime equal to 6 volts. Now we have to check whether it is plus 6 or minus 6, right? So we are getting like this. So current is flowing plus minus like this, but they have given in opposite way. So this minus is we have to take. So Vx prime is minus 6 volts. So finally you write by superposition theorem Vx equal to Vx single prime plus Vx double prime plus Vx 3 times prime. So therefore Vx equal to, so Vx prime was 3 volts plus 3. So 3 Vx double prime is minus 5 and Vx triple prime is minus 6. So therefore Vx equal to minus 8 volts. So this is our final answer. Again, this sentence is very important. By superposition theorem, it carries 1 mark. If you directly write Vx equal to this or Vx equal to this also, then you will lose 1 mark. Okay.